Okay, we're good. Okay, so in the reading it says, give the test specific statistic and its value. The test is statistic involving paired data when O is unknown is a T for this solution. So I think we use that equation of something minus something. Then the bottom is this, the square root of whatever equals T. So I think that's the test statistic then.
Oh, okay. So that would be.
So it's like the Z-score. So we would need the stuff we had back in chapter, I think it's lesson 11, the formula.
Yeah.
Let me
open. So then in this case, it would be 2.2 minus 0, 3.3 divided by square root of 9. I think that's right. Because the 0 is based on the null hypothesis.
Right. So how do you remember that? The T equation?
Oh, I just looked at it.
Oh, I was like, crap. I was like, where did that even come from?
Yeah, I looked at it. Right when you said that, you triggered like, oh yeah, I know what the equation is.
I was like, I don't know whether to feel really stupid at this moment or just really glad that you remembered that and I didn't.
No, in fact, now that you say that, I should go back and make sure I got it right. Yeah, that's how it is. So it's 2.2 minus 0 divided by 3.3 divided by the square root of
9. So that's going to be 3 divided by 3. Hey, did you get 2?
Yeah, I'm wondering if that's right.
Okay, so in the reading, it says, and I looked up test statistics. Hold on. I think that is the right thing.
Yeah.
Because it says the test statistic T is labeled on the horizontal axis of like the probability applet. The p-value is the area to the left of the t under the score. If the area is too small, it is not illustrated on this plot. Please note that the image, okay. The test statistics for 2 means with paired data is a t. The image was designed for a z-score. Okay, I think it is 2.
Okay.
What do you think though?
That's what I'm going to put.
Yeah, I feel good about that. Okay. The probability of obtaining a test statistic greater than Jordan's test statistic. Why can't I say that word?
Stat. Just call it a stat.
Stat is 0.043. Uses probability to determine the p-value for Jordan's hypothesis test. Okay.
Wow. So find the p-value and compare it to the value.
Sorry.
So this is another one where I don't remember how to calculate the p-value because the Excel has always been giving it to me.
Okay, so in the reading it says,
I think we're supposed to use it halfway.
yeah, because it says it is important to note that, okay, so find the p-value and compare it to the level of significance. It says p-value equals 1.06 times 10 to the negative 11th is less than 0.05 equals.
Okay. Yeah, so I think what we do is we plug in 2 as the t-score.
Okay.
And I think we highlight to the left.
Okay.
Let me just reread the question.
Oh, so where does the 0.043 come in?
So, hold on, let me just read the question. I think if they're asking if it doesn't equal 0, I think you highlight to the left and to the right. And I think the comparison is the p-value is 0.1393. At least that's what I came up with.
Okay. Yeah,
And
0.1, that's the area. So is that the p-value?
that's the p-value. Probability. Or is this a trick question?
That's what I'm wondering.
Is that the answer? 0.0403.
That's what I'm thinking.
Mm-hmm.
Oh, well, I don't know. Okay. Let's see. All right, let me look at the reading a little further. Please hold.
Why is the area to the left of the t-curve? The area is so small. I don't know. I think I'm going to go with the t-score applet thing where I've highlighted the left and the right side.
Yeah, hold on, sorry. I'm just looking at one more thing. I think that doesn't make sense though. I think I don't know.
Well, I'm saying the same thing. I don't know either. I think though
There has to be another way to get to the answer though, because I'm not sure if that's the right answer.
Yeah, I think it's either I think the answer is either the given, the 0.0403, or we were supposed to take the t-score from the last question, and then I think you highlight the left and the right side because the question is asking you for what doesn't equal 0.
Oh, you know what I think we do? Okay, so this in the reading, it says the p-value. Okay, so it says you plug in the two values. So the p-value is the area to the left of the t under the score. But what I'm wondering is where if we everything under, sorry, I'm up on my end, hold on. If we do everything under the t-score and then type in the number, that number they gave us, and see what happens. Because that number has to be used for something, right?
Yeah, that makes sense. But I thought that what determines what you highlight is whether or not it's asking you if something's less than, greater than, or not equal to.
Okay.
And this one's asking us for something that's not equal to.
Okay.
Which is that two-tailed. I'm probably totally overthinking this. Let's plug in that and see what happens.
I'm just curious.
But what 0.04?
I don't know if that's right either, though.
So that changes your t-score, though.
Yeah. I don't know.
I'm going to go with 0.102.
Okay.
I mean, either that or I was going to put the 0.0403. I acknowledge that both of those might be wrong, though.
Oh, it was 0.182. Sorry, I got rid of my.
0.102 is the 3-digit,
Okay.
3 decimal place one.
We'll try it and see what happens, right?
Yeah, I mean, worst can happen either way.
Both get it wrong and we'll try it again. Okay.
Open data 1A.
Okay. So we need to use the A1 data. So do we just type that? So, okay.
So I plugged it into that quantitative inference.
Which one did you type in? The group 1 or group 2?
So if you go down to the bottom, there's a tab that says paired sample t-test.
Ah, look at that.
And that one gives you the ability to do 2 different variables.
Okay.
So it'll do all the math for you.
We just have to enter in the appropriate data.
Mm-hmm.
Okay. Peaceful.
1 minus 2.
Are you going to be glad when this class is done?
I already am glad, and it's not. Yes, I will be. This has not been my favorite class.
Mine either. I think accounting has been worse, though. I'm not going to lie.
Oh, geez.
You've taken accounting, haven't you?
I took it a long time ago, and I still don't know if they're going to accept the ones I took 20-something years ago.
Are you serious?
Yeah.
Oh my gosh, I'm going to cross my fingers and pray that they take it because
I'll take everything I can get.
accounting sucks.
Yeah.
Okay, so do we need to change anything in the null hypothesis, the confidence level?
Not that I see yet. They haven't given you anything in these first questions to do anything with that yet.
Okay.
So
I don't see a test statistic.
So if you look down to the last box, it says paired sample t-test.
Yeah.
The t in the differences is your test statistic.
Oh, that's my test statistic. So I got 0.407. Is that right?
Yeah, that's what I got too. So if I get it wrong, you got it wrong. Yeah, we're good.
Sweet.
And then the p-value is the next one over. So 0.689.
9.
And then what is the correct decision?
Okay.
Oh, here's where it gets
tricky. Okay, so here's a great thing. We have a 50-50 chance. So
yes, so since the level of significance that we're measuring against is 0.1.
Yep, and this is 0.4. So does that fail to reject? Or is it reject?
Well, do you use the T or the P? I thought you used the P.
You use the T.
Oh no, I thought I used the P. Hold on, let me look back at the. I thought it was the P, but I don't.
Well, but either. Hey, stop.
Yeah, that's a good point. Either case, they're both
more than 0.
Yeah, that's a good point.
I mean, or more than 0.1. So does that mean it is failed to reject?
Failed to reject, yeah.
Okay.
Hold on, sorry. Let me look back at the question.
You're fine.
The data. The null hypothesis is if it doesn't equal 0. So yeah, if it's greater than, you fail to reject.
Okay, so then it is fail to reject, right?
Yeah, and unless it isn't, then it's reject. Yeah.
I have no idea. If what you read is correct, then it's fail to reject, I think.
C, I don't know, isn't one of the choices, unfortunately.
Hey, but it's only A or B, so I feel fine about that.
Yeah.
Okay.
Greater than 0.
Sorry, he's barking. He's like really excited.
Okay, so since the T or the P is greater than 0,
That
and
means
we would
the
have sufficient
evidence?
evidence
that the mean of the differences is greater than 0?
is greater than 0, because that's what it's asking us.
Yes.
Is it greater than 0? So yeah, that's what I think.
Feel good about that.
So C.
Yes.
Okay, here's the other thing.
Okay, so now you want to grab the data. C. Okay.
Okay, so be sure that the test is 0, 0, 1.
Okay. What is greater, N or?
And N is always greater than DF because DF is N minus 1.
Oh, okay.
Boom. Don't ask me how I knew that.
Good job, Greg.
I have no idea how I knew that or how I recited that. Okay, p-value.
0.001.
Yep.
Yoki. Okay, so it is greater than 0.01. So does that mean fail to reject then, based on what we said before?
So the level of significance is 0.01, and we're trying to.
Oh no, it's smaller, so it's the other one.
Yeah.
So it's
so
reject.
Now we're going to reject the null hypothesis. Yeah.
Okay, you decide to try another alternative hypothesis. This time you will use
Oh, did your p-value? Oh, so we can do that actually. Let's change the type of test to.
So the p-value, mine decreased, but tell me what yours did, because I changed it to greater than instead of not equal to.
Mine went up, yes.
You mean went down?
Went down, yes. Thank you.
Because it was 3 zeros and then a 6, not a 2 zeros, or no, it was 4 zeros, then a 6, right?
That's almost thrown me off. I just saw it went from a 1 to a 6. But yeah, no, that's right.
It's okay. I saw the same thing at first. I was like, oh, it went up. And then I was like, oh, wait, no, it did not.
That's almost thrown me. What decision do you make?
So reject?
Yeah, because it's still
Smaller. It's not greater than, it's still
0.01. Yeah.
The other one.
Right. So, I'm sorry, did we say fail to reject? Because
no, I think that means it will be reject, because we've said when it's bigger, then it's fail to reject.
That's
if it's
right.
smaller, then it's reject. Or I'm assuming it's the opposite. I'm just saying what you said.
Yeah, no. Yes.
Wherever that came from.
I have no idea where it came from.
I don't know either, but we're going to go with it. We got a 50-50 chance. Okay. So based on your response, what conclusion do you come up with? Okay, so.
Since we're rejecting it, we have insufficient evidence that
there is a mean difference, or there is no mean difference?
I'd say that there is no mean difference, but I'm not sure.
Okay, I have no idea. So, but we know for sure that it is, we have insufficient evidence because it is reject.
Yeah, that's how the other ones have been, at least.
Okay, so we'll try.
That's the pattern. I have no idea. That's the pattern. I don't know if that's the.
We're gonna go with it.
Actual logic behind that.
We'll try B, and if not, then we'll try D later.
Yeah.
Okay. As we have seen, the p-value depends on the alternate hypothesis. In general, which alternative hypothesis hypothesis will give the smallest p-value? I don't know.
Good question. Let's play with, let's manipulate this thing and see. It's not less than. It's probably the one we just did, the greater than.
What about less than? I'm just curious.
Well, when I plug in less than,
Oh, it gets way bigger.
it gets way bigger, yeah.
So yeah, I'm going to say greater than. So D.
Mm-hmm. And if it's not D, I think it's C.
Okay, I agree. I concur. Okay, determine the 95% confidence interval for the mean difference between two groups. Input your answers below. What is the, what?
Okay, so this is given in this thing. It's the 5.303.
Okay.
What is the point? Oh, wait a minute. No, sorry, this is a different question.
Yeah, no, because it's not the lower.
Yeah, this is asking.
That would be the answer to 18, though.
Are they asking for that?
Yeah, 5.3
Oh, cool.
in 18.
What is the point?
And then the upper one is 18.607, and that's 19.
What is the point estimate? Is this the one where you subtract them?
Um,
Point estimate. Doesn't show up. Great. I feel like this is a trick question.
I kind of do too. I feel like did we have one of these last time and we were like, I have no idea. Okay, hold on.
We go back up to the information. Determine the 95% confidence interval for the mean difference between the two groups. Okay, we have that there. Now it's asking for that. What is the margin of error? Oh, I see what you're saying. The lower bound one is that. So it's 5.43.
Oh, is it the mean?
And then the margin of error would be the standard deviation.
I don't know. Let me look.
The mean would be 11.955.
Because
It wouldn't be to test the T, would it?
I don't think so.
I like your idea. Let's go with the mean. 11.955.
Yeah, but then how do we find what is the margin of error?
Well, I think it's telling us standard error of mean 3.199. What a guess. I think it's the 3.199 or the standard deviation.
Would it be, hold on.
It wouldn't be the P, would it? Because it's asking us for the point estimate. The P value is the probability.
Yeah, the p-value is the probability. Oh, I don't know how to figure this out. Hold on. Let me see. Um, sorry, I'm just looking at the reading.
Yeah, I was skimming through it too. I'm not seeing anything.
Okay. Oh, this is irritating.
I'm just going to go with that one.
With which one?
I plugged in the mean, and I plugged in the standard error of the mean. I don't think that's right, but
3.199.
yeah.
Okay, let's try it.
And then the confidence, what did you have? Did you have 5.303 for 18?
Yep, and then 18.607 for
The
19.
only thing I wanted to just check was if we change that doesn't change those.
The
That
type
only
of
changes
test, the only
value.
thing that changes is
Yeah,
the value.
okay. So I think that's good.
Okay.
Let's see how we do.
Let's see. Dang, that's the worst we've ever done.
Uh-oh.
75%.
Oh, wow. That's better than I thought we'd do, though.
Yeah, I thought we were gonna do worse. I'm not gonna lie. Okay.
4.
So
Oh, 4 we weren't sure of, yeah. I bet
yeah,
you 4 is just that trick question.
yeah. Look.
And then 8, yeah. Okay, so I have all of those backwards, the sufficient or insufficient.
Okay. Hold on, Kate. I'm gonna open the quiz again. Hold on, and I can read them off to you. Do you want me to?
We got 17 wrong, and we got 16 right. That's kind of shocking.
Okay, hold on.
What is 17?
Okay. Try this again, shall we?
Yep.
Okay, do you want me to read them off?
Yeah, hold on. Let me. Sorry, I'm.
No. You're just fine. I'm just
still trying to load. Okay. What did we 3? Did we get wrong? 3 wrong, or
yeah. No, 3 we got right.
what was it?
2,
Oh, that's right.
but 4 we got wrong.
Yeah.
So let's look at that.
I think it's tricky. I think we just need. I'm gonna put that 0 point or 0.0403.
But what if?
Greater.
Hold on, let me think. Use the probability to determine the p-value for. I have no idea.
Me neither.
Should we just guess and see how we do?
Yeah, I'm just gonna put that and see what happens.
Well, I wonder, what if it's double that?
Double the 0.403.
Yeah, so if it was like 0.81.
Oh, the other thing we could do is, what if I've still got that T-score thing open.
Yeah.
What if we unclicked the right one so that only the left ones, or if we did the middle
Hold on.
greater than, maybe if it's greater than, we should probably just do the right side, which is 0.051.
Put us at 0.697. Is that right?
I got 0.051. So do you have 2 as the T-score?
Yeah, I have 2 as the
If
T-score.
you check the right side?
Yep.
Right.
With 3 degrees of freedom.
Oh, I don't know why mine has 5 in there.
Oh.
That's weird. Do we even know what the N is?
You mean the degrees?
It should be 8.
Mine says 9.
Yeah, so the degrees of freedom is N minus 1.
So 8.
Yeah.
Okay, I think it might be left and right.
Oh, that's crazy. It's the same answer, 0.0403.
Yeah, so I'm wondering if it's not that 0.043 and if it's if it's both, because that's both sides.
Yeah, but you usually only do both sides when it's asking you if it's not equal to 0. This one, oh, I guess it is. Like the information says that it's the alternative hypothesis is that it's not equal to 0, which would be both sides of the.
We want to try that?
Yeah, that sounds good. So 0.805 or 0.080
No.
or say
0.081.
0.81. Yeah, let's try that one.
Okay. All right. So for 5, did we get it right? We got it right. 0.407.
Okay.
And let's see if we got the p-value right. We got the p-value right. 0.689 for number 6.
0.689.
Got it.
Okay.
And then 7, we got right, which is fail to reject the null. Okay. 8, we got wrong. So hold on. Before we have sufficient evidence, but the thing is I think we got the other ones wrong too. So I'm wondering if it's not flipped and it's not that we have insufficient.
Yeah, I'm trying to find an example in the homework or the lesson that might help us. So this one is, in this particular one, I'm in, I don't know, the one like right below the x-ray, the chest x-ray.
Okay, hold on.
Step 4, they rejected the null hypothesis, and the answer, the English answer is there is sufficient evidence to suggest that the mean, the hospital stays. So
Everything else the same.
when they rejected, there was sufficient evidence. So what did we figure out here?
Okay, so since the p-value is less than the level of significance we reject. So that doesn't say anything, though, about sufficient evidence.
Yeah, I think it's though. I think it goes with when you reject, there's sufficient evidence. I don't know. Maybe I think that's the logic that got it wrong in the first place. But
Well, the only reason I say it might be wrong is because I think we got those other ones wrong too. So I'm
yeah,
wondering if it's flipped.
it's either flipped or it's because we picked the wrong sufficient one.
Dang it!
Which is possible.
Yes. I don't know. What do you think?
Which one did we pick for this one?
We picked C. Because it's not equal to 0. That's my only problem. We know it's greater than 0.
Yeah. Which one do you think it is?
I think it might be B. Only because C, the only thing that's different between B and C is saying insufficient versus sufficient.
Yeah.
And then they're the same in that they say they're greater than 0. And we know for sure that both the answers we got were greater than 0. They weren't equal to 0.
Okay. Works for me.
Okay. So that's just my crazy.
No, I like it.
I guess. I don't know.
Perfect.
Okay.
So 9.
9 we got right, and the answer is N. Okay, 10 we got correct. It's 0.001. And then 11 we got correct, which is reject the null.
Okay, so let's follow the same logic that we did
Okay.
the last time. We failed to reject, and we said we had insufficient evidence.
Yes.
So this time.
So I don't know if we have to do that on this one yet, though.
Oh, cool.
Thankfully, but we have to do it in a minute for a different part.
12.
12 is decrease. 13 is reject the null. Okay, so 14, we have insufficient evidence, so hold on.
Well, we rejected the null on 11.
Yeah, 11 was reject the null.
And then 7 was fail to reject. Okay.
Yes. No. Oh, and 7 was fail to reject?
7 was fail to reject the null.
And then 13 was reject.
Yeah.
Okay, so
I'm thinking it should be the sufficient one. But let's see, what's the original question?
So maybe C then?
The alternate hypothesis is not equal to 0.
Because we do know that there was a difference between the two groups, right?
Yeah. What did we pick?
Yeah, I think it's C.
What did we pick before?
Huh?
What did we pick before?
We picked B before.
Okay. Yeah, let's go with C.
Okay. Okay. All right, let's see. Did we get 15 right? 15 we did not get right, and we put D. So does that mean we think it's C?
P-value depends on general.
Because what I'm wondering is maybe it's
so.
Because I know it's for sure not the other ones, because there's no way that it's the less than one, because that one made it big.
Yeah.
But the other one, it may be like a minimal difference. I don't know.
Yeah, I like C.
Okay.
And at the end of the day, if I get another 75, I'm still happy.
Hey, you know what? I think we're just going to do better than we did last time, which even if we get one or two more, we get like in the 80s, I'd be fine with
Yeah.
that. Okay, so 16 we got correct, and the answer to that is 11.995.
Okay.
Wait, let me double check that again one time. Yeah, 11.955.
955. Okay.
Okay, 17 we got incorrect, but we got 18 and 19 right. So should we plug in 18 and 19 and see if we can revisit?
What are those ones?
17?
What's 18?
18 is 5.303. And then 19 is 18.607.
Okay.
So, oh wait, I just put those in the wrong ones. Please hold.
What is the margin? I feel like the information should be on this,
Okay.
somewhere in this Excel thing. What did we plug in last time? 3.199?
Let me double check. Yeah, 3.199. What is the margin of error? So how do we get the margin of error?
I hate how you go through the reading and you have certain terms, and then like when you search the word margin of error, it doesn't even come up in the lesson.
No, that's what's irritating to me too. I'm like, how do you expect me to know the answer to this?
Yeah.
I'm like, you don't teach me. I feel like it doesn't appropriately teach me.
Well, I wonder if we should put in the standard deviation for the differences. 15.003.
Differences. So 15.003.
Yeah, even though I know that's not what a standard deviation is, though. That's the standard deviation is a measurement. It's not a margin of error.
Yeah. Okay. But standard error of mean. Okay. Let me see if I can find something online that says what is the margin of error. Okay. Oh, okay. It can be the margin of error. It can be calculated as a multiple of the standard error with a factor depending on the level of confidence desired. A margin of 1 standard error gives a 68% confidence interval, while the estimate plus or minus 1.96 standard errors is 95% confidence interval, and a 99% confidence interval runs 2.58 standard deviate errors. But how do you find that though?
I wonder if this is pulling back on the knowledge of that. Remember that rule, the 95, 97, and no, that's not it. Sorry.
Yeah, well, this
66, 66, 95, and 99.
Okay, so there's this thing that says margin of error is critical value times standard deviation. Okay, margin of error also equals critical value times standard error of the statistic. So, hold on.
This sounds dumb, but it wouldn't be 0.05, would it?
I don't, let me see, hold on.
If
No,
our
because
confidence interval is 95%.
I don't know if that would calculate to our margin of error. Well, hold on.
I have no idea. Anything I put is going to be a guess, honestly.
Okay, so the critical value is either a t-score or a z-score. So
we have a t-score.
Step 1, it says find the critical value. Step 2, find the standard deviation or the standard error. Then what we want to do is multiply the critical value by the standard deviation. Okay. So the critical value is the t, right?
Yeah. That gives you like 56.178.
That can't be right.
Doesn't make sense.
Okay. Or, hold on. Critical value or the z-score. So t-score. I have no idea.
Yeah, I'm just going to put hold on, I'm looking at her notes from this week. Sometimes she has good stuff in there, the teacher. We can find the value of the margin of error using a backdoor approach if we know the lower bound and upper bound values of the confidence interval.
Is it that easy?
After inputting, yeah, there's actually a formula in here she has.
What?
Yeah.
All right, what's the formula?
So it's the confidence interval divided by the lower bound and upper bound values. Where's the 2 coming from? I'm trying to figure out the formula.
No, you're fine.
But she has it in here in the lesson notes.
Oh, she does?
Yeah. Okay, so the 2 is coming from the confidence interval midpoint. The margins of error. Yeah, I'm reading this, but I'm not understanding it. So
No, you're fine. Is it in the announcements?
It's in the announcements, yeah.
Okay, let me see if I can find where you're at and see if I can help.
It's right above like all the due dates.
Okay. For lesson 11, right? No,
12, 12, yeah.
Okay. Confidence interval, point estimator minus margin of error, point estimator plus margin of error. Okay, so confidence interval has a lower bound and an upper bound. Lower bound, upper bound. The confidence interval's midpoint is the point estimator, and the total width of the confidence interval is 2 margin of error.
That's why it's divided by 2.
Okay. So, hold on. So does that mean it's No, okay, hold on.
So I'm wondering if it's just as simple as the 18.607 minus 5.303
Divided by 2.
divided by 2. Better than the other guesses.
Wait,
Six.
18.607 minus 5.303 equals divided by 2 equals. I feel fine about that.
Yeah.
So 6.652.
Yep. Works for me.
Right. Good news.
Whoa.
We got 100.
That's crazy.
Go us.
Dang, I'm not impressed very easy. That was impressive.
Yay!
Oh, way to go.
Go us.
We powered through that one.
Yeah, we did. But hey, it was still, well, it was right about an hour.
Yeah.
Not bad.
Now I know how to find the margin of error.
Yes, I'm never going to forget that.
That's sealed in my brain.
Yep. One of those things that's just going to spit out of my brain
Exactly.
from now on.
Cool.
Cool. All right.
That's
Well,
good. Thank
have a
you.
good evening.
You too.
I should be there Wednesday.
Okay.
I have a mutual activity that they're doing later, but I think I'm just going to skip out early.
Okay.
So
So Wednesday we're doing it
8:30.
8:30. Yeah. Okay.
30 our time, 7:30 your time.
Yeah. Cool.
Okay.
Thanks.
Awesome. Yeah,
Right.
no, thank you. Bye.
Take care. All right.
Thank you. Bye.